plus a surface normal times this very small number, and that is going to be the suggested new position. So what we're going to do is this should snap us down. Kind of like if we're running down a hill, we have, well, it's kind of, if we're running down a basic slope like this, we're already moving in this direction. So we should just be right here, and that should be fine. But if our hill kind of goes like, you know, if it's a staircase, and we've moved out to here, it should snap us to the staircase. So we want to do that. The other case is if the surface curves like this, and we move out here, so we're like right here in the air, it's going to snap us down as well. Of course, this means if Bitey is running downhill, he might actually move faster than normal, which is fine, right? Like that kind of makes sense. He's kind of breaking physics in reality doing it, but that's okay. He's going downhill. He can do that. And if Fat Sack's doing it, we're just going to blame it on him rolling like Thudbutt and Hook, knocking all the pirates out of the way. But what we don't want to do is move up. Like, but I don't think we're going to have that problem. Like, at this point, like if we're moving surface normal here, if there was like a step in the way that was preventing our sweep test, oh yeah, we're gonna have some problems here with stairs going up, aren't we? We're gonna have to figure that crap out, because our sweep test is gonna put us right here, and then we're gonna have like that whole mantling crap we have to deal with. Well, let's get there when we get there, one step at a time. In this case, literal stair steps. So we don't want to move up, so we're gonna say if our new position dot z is less than suggested new position, then our suggested new position dot z is going to be new position dot z. And there might be another thing here. So if this is suggesting that we move backwards, like I mean, we might just want to set our position to this new position properly and then do an overlap test. So that's what we should do. We should just say, okay, well, if that's the new position that we should be in, why don't we just try to be there? And in order for us to actually be there, oh, this is wrong. We need to take all this stuff and put it outside this for loop. What am I doing? So we're going to need to actually not do a sweep test on this suggested new position, but we're just going to do an overlap test with the world. So what is the overlap test called? There it is. Get sweep component, overlap shape. Do we have overlap component? We do not have overlap component. Well, that's something we need to make then, don't we? Let's see exactly how we need to make that. So overlap multi by channel is what we're doing. So let's go check uworld. Overlap component. So we got a collision shape, async sweep. No, we don't want to say async sweep. What would it be called? So we got like sweep multi by channel, which is taking channel. sweep component is called sweep multi by channel, so it's going to be overlap multi by channel, probably is going to be the name of this thing. Yeah, so here it is. It's taking a primitive component and all the rest of this garbage. So we can actually just go ahead and do that. So it's component overlap multi by channel. So let's go ahead and make these functions for ourselves. Alright, so we're going to have overlap shape. It's going to be overlap component. Overlap component S. The S stands for simple, I believe. And yeah, we'll have our ignore actor again, and we're not passing in a collision shape, we're passing in primitive component. And again, we're not going to want to be dealing with those stupid casts, so we're going to go ahead and make a paper physics component shape as well for these. I'm actually liking streaming some of this coding work because I'm less likely to just like zone out and look at Reddit for 20 minutes and then be like, well, I'm kind of hungry. I think I'll go eat something. And then all of a sudden it's like 6 o'clock and I'm like, well, you know, it's like late or something. Maybe I should like, you know, play some games, or I've worked enough today. It's like, nah. Streaming stuff is actually like, you got a little clock down there and it's like, we've been streaming for an hour. It'd be like, hey, you only been working for an hour, you need to do more work, what are you doing? Fine, get to work. Keep me a little bit more honest as a self-employed person. Honesty and accountability are pretty important. Overlap component sucks. Stream says don't be lazy. Yeah, I do a lot of things to try to keep myself from like going freaking insane, because you know I've always been working in, you know, a big studio and stuff like that with 60 other people, and you always got, you know, somebody, there's always something to do, somebody always needs help, everything's always busy, so if you're like, you can always be useful somehow. But when it's just you know, there's nobody there like giving you a hard time if, you know, you're rolling to work at, you know, 1 in the afternoon and, you know, you're just not doing too much good for anybody. So we need UWorld back. So I do a lot of things to try to keep myself on task. Like, I keep a journal of what I do every day. It's also something I got Adam to start doing too. Now he's writing in a little journal to help keep himself on track. So we need to pass in the overlap results, then the primitive, the position, rotation, hits, primitive, position, rotation. Yeah, we don't have an end to the vector. The params, and then the query params. Collision object query params. Collision object query params. Component query params, and then the collision query params. Collision object query params. So we have component query params. Alright, that's fine. And then we need the collision query params. So we're going to have these object params. Yes, without peer pressure, definitely. It can be difficult. So let's see, we don't need the end. We will reset hits. And we're casting our shape. I mean, not casting, object params. We're overlap testing. Rotation is... Where are we getting our rotation? I don't see a rotation anywhere. So we need to make a rotation? Yeah, here we go. That looks better. And again, it's returning a bool. What are you upset about? No instance of overloaded function takes the things you are passing. So nothing takes the overlap results and then a primitive component pointer, which we've got, and then a quaternion. Yeah, it's our... Yeah, I think IntelliSense is just being stupid. So, we've got a rotation, so we don't need that. And that should do that. So hopefully, we've got our overlap component done. So what we're going to do is basically, if our overlap component fails, then we're not going to move to the impact point. So, we want to do overlap component. We don't need a direction. We do not need a distance. Is it really just 3 parameters for this thing? Well, we've got a channel. Well, we don't need a channel in these guys because we know the channel based on the component, so we can remove that from our params. Our ignore actor is null, so we just need a position, a shape, and hits, and we're just using overlap component S. And yeah, it's only 3 params. That's pretty good. So let's chunk off all these things we don't need. Goodbye. Goodbye, channel. We don't need you because we already set you somewhere else. Not a problem. So, if we do actually overlap a component, we'll just throw a bool in here for like hit and set it to false and say if hit is true and break the loop. And so like if hit, if no hit, then we're gonna set our position to the new position. So should we actually set our position right here or not? Doesn't look like it. We should probably just call internal set position after all this stuff, and we should just set new position equals suggested new position. Something like that. Alright, so this is going to be the hit distance was, this is, we did not hit anything with our array, with our sweep, so move along the surface. Not bad. Having a deadline? Any deadline, yeah. So what we do, if you're curious at all, I'll throw up a little bit of stuff here for you. Basically, we've got these weekly things here that we do, where we write down what we're doing, and it shows like charts and graphs and all these things. So like, this is this week, and I've been working on, like, it's like we need 2D characters in Unreal, and you know we have like, it'll sum up all the estimates that we throw for our tasks. We got it broken up into line items, and then we've got like this little array of stuff. And when we say like we've done something, like we're working on physics right now, and it's Thursday. Hey, this is the wrong week. Like if we say, okay, well we're closing in on stuff, so if we put a 3 there, you can see it'll update over there and set our velocity and all those things. And what we try to do is basically these tasks are what we plan to do. And so there's been a lot of stuff like yesterday and all that stuff. I had to fix a whole bunch of bugs, and like I had to fix the build this morning because it was broken. Those little tasks we don't represent here, they kind of get wrapped up into overhead, quote unquote stuff that we do. And at the end of the week, we kind of like see like, well, how much did we get done? And we give ourselves the number of points that we expect to get done next week. And that way we can kind of estimate on our long-term calendar if we're actually going to get stuff done. And the whole point is the numbers are all magic and really don't mean a whole bunch. You just kind of say like, well, this is a 5. And by kind of law of large numbers and randomness, usually come with very accurate estimates for what we do. And every week we have a call, and we basically just say like why we didn't get stuff done that we wanted to get done. And there's no like, you didn't get this done, like, oh my god, like we're gonna kill you. But you at least have to show up and say like, I didn't get this done because, and then you write down the reasons, and then you take the reasons, and the next time we're doing our sprint planning, we'll be like, well, last time, we wrote down that we had a problem here. Is there anything we can do to fix that? And that helps us keep a little bit organized. And for this week, it's actually going to be like, this is the first week where I've been streaming a whole bunch of coding work, so it'll be interesting to see how much my velocity changes. Velocity being how much work I get done. Yeah, that's what I used to do at EA2D when I ran teams there. So what I did at Molten Games is what I did at Amazon for all the teams that I ran. Is you just do it that way, and you just write everything down, even if like you don't agree with it and stuff like that, and you just bring it up and talk about it. And we always tried to do 1 week sprints, because 1 week is really good, especially if you end it on a Friday. That way people aren't freaking out because over the weekend, like you don't have any assignments over the weekend, you failed to get your stuff done. If you're going to get it done, you're not like saying, well, it needs to be done Monday because Monday is the end of the sprint or something. It's set up so, it's always, if you didn't get it done by Friday, then, well, just enjoy your weekend. And a lot of the times we got everything done because it was okay to fail on my teams. It was absolutely fine to screw up a task and not get it done. It was only a problem if you didn't say that it got messed up, and if it was a critical path task that got messed up, if you didn't ask for help. Like if you didn't say it didn't get done, and you didn't ask for help when it was critical, that's when we had a problem. That's the only times we had problems. What is this weekend? Yeah, I pretty much, like, since I was always the team lead, I had to go, like, I worked pretty much every weekend. Oh, we don't actually want to call by channel. We just want to call overlap multi, I'm pretty sure. Yeah, here we go. Just got the wrong name there. Yeah, that was always the best time. Like I'd get like all my work done on the weekend when I was there, especially at Amazon. Just the overhead of just meetings with everybody just sucked. So it'd be me and some other people just doing the weekend warrior stuff because They could actually just sit there and chill and like get work done without 200 people running up and being like, "Oh my God, this thing is broken," and I'm like, "You broke it. Why don't you fix it?" No, I wasn't that mean. Well, maybe I was. So we're not passing in a rotation, so I think we need dir S. Closest distance to floor is greater than G down. It's not down, it's physics far enough. Sweep component dir S again. Sweep component dir S again. Overlap component S. Alright. Yeah, I was definitely why I was there on the weekends. And also freed it up like during the week if you just if you needed if everything was just going wrong, because I was a server engineer, so we were running servers for the rest of the studio and sister studios. So if something was messed up, like sweep component dir S is not member of physics utils. It's sweep component S dir. All right. Good. Impact point. Impact point. Yeah, we need to set this equal to 0 vector, not constructor. Since we were running like all the servers, infrastructure, and tools and all that for the project, basically there was always somebody who needed a little bit of help, even if it was just like something we'd already solved. We're like, did you sync down Perforce? Did you run the file? Did you read that email I sent last week? It's just always something, and you can't really blame people for not reading emails because everybody there just kind of trying to do their best. This is an update locomotion. Where is the transform? Alright, so this is going to be the surface rotation transform. Yeah, that's been one of my problems is I'll wake up and I'll just be like, what year is it? Which that's been even more fun working with somebody who's in Australia. Because it's like, which day is it? Saturday or Sunday? And it's like, yes. I'm like, no, damn it, it's both days at once. Because international dateline. And my schedule has basically been like rotating around. So some days I'll be getting up when Adam is going to sleep, and other days I'm waking up after Adam wakes up. And some days I'm awake the entire time Adam is awake and more, and then I sleep the next day entirely out. I think Adam's given up trying to sync our schedules or have any sort of thing like that. Okay, so what is this? This is overlap component S, which is we are passing in. It's getting angry at us. So we should give it a position, a shape, and a hits array for overlap results. So it's probably that we're giving it a hit array for, we're giving it an array of F hit results. So what we need is the overlap results. So overlaps is what we need here. That's looking good. Very good. Let's see what everybody's up to. Sweep component is calling itself. Oh no. Oh god, that's a really good point. I need to be casting this thing, don't I? So, sweep component needs to cast to a U primitive component. So paper physics, primitive here. There we are. Probably need to do that for overlaps. That looks good. So with this, I think we've implemented a few parts of moving around here, which is we're doing a sweep test in a direction, and if there's no collision, we are snapping to the ground. So I believe we should be able to like run left and right, something like that. We'll find out real quick. So we should be able to place ourselves on the ground and then run left and right. That's the idea. And when we run into a wall, we should do nothing. We'll just run into the wall. We will not be able to move into that wall. And of course, this is what happened. We're just stuck in the floor. So let's fix that. I think it's because we are initially setting ourselves to be stuck in the floor, and that's going to be with our update locomotion on ground. No, it's going to be our discover physics state. Oh well, it was all fake. Like it was all just garbage. Like the code we had written for the ray casts for running back and forth was, we assumed that the object was a sphere, and we are now using, you know, the actual bounding box of the fat sack dude and all that stuff. So what we're gonna do is refresh ourselves for what actually our setting our physics state is going to place us. Yeah, we had just thrown that basic movement in there to make sure that like our ray casts were working and all of that, and also just get some basics. So now this is actual movement that will be actually not crap, hopefully, and we're doing it one piece at a time. So let's see, we've got our components, which is one physics body. And okay, so shortest distance to the ground is going to be, we're sweeping from -10 set 620 down, and our shortest distance is going to be 514. So we're setting our position is going to be the position direction times shortest distance. So we are now on the ground, and our position is this thing. I mean, this is going to place us... We don't actually want to set ourselves right here, we're gonna want to do. We're gonna want to grab the normal to that surface to put ourselves on the ground. So F vector, surface normal, and we're gonna want to push ourselves a little bit out. So we're gonna need the impact point and the surface normal. So surface normal is going to be last dot normal, impact normal, and the impact point is going to be last dot impact point. So we're going to set our position to the surface normal times the, it's going to be the impact point, surface normal times, not the shortest distance, but we need that tiny distance, that penetration distance. So it should do that. And then we'll do an overlap test here to make sure that we can actually exist in that location. So we've got our overlaps, bool hit equals false. So if hit, then what are we going to do if we hit something? Well, we just won't move ourselves. So we're just going to, if not hit, set position equals that. So if we do hit, then set position is just going to be our current position. We couldn't exist on that ground. So we'll just see what happens. A lot of this is just going to be some trial and error, and we're not going to have like the movement actually working here until we get like all the pieces of the movement working. Because like we won't be able to leave the ground until we implement like jumping, and jumping means we need to transition the states and do all the things. So, and then jumping needs to work properly so we can go into flying, and then when we're in flying we have to implement that so we get back to the ground. So it'll be like as soon as you hit the up button or the jump button, your guy just freaks out and never returns to reality. So when we start this guy, we're going to discover our physics state. So our shortest distance is less, so we actually do hit something, and our position is going to be this 38, negative 5, 107. So what is the surface normal? Surface normal is basically a 0, 0, 1. So we didn't hit anything, or did we? Looks like we didn't hit anything, so we set ourselves to being in the ground. So that is where we are. How long do you reckon? I don't know. We'll figure it out. So let's see. Yeah. Ooh. So we can kind of move a little bit. Or at least we were there. Like, if I hit the arrow key, I can kind of move. What the hell? We're trying to move in the X direction? The movement direction is -1. Alright. So we are actually setting ourselves properly a little bit, and it looks like probably the component position for the sweep test is not set as it should be. I might need to find the component specific offset from the parent and then use that position for the sweep. Some I had written down yesterday because that would make sense, because right now if we pull up FatSack in the content browser, I take a look at his collision boxes. You can see the collision boxes are lower than the center. Like if we zoom way in, unlike him sitting here, right? So this is his origin, and this is the box. And he's sitting kind of where the box would be if the box was centered on him, not offset. So, you know, like when we hit play, FatSack is sitting there, and it looks like, you know, like if I call show collision, well, I can't really see it because the camera's too far away. But the collision is there on the guy properly, but it would be offset. Anyway, so obviously our rotation about the X axis here was incorrect, because we rotated and then we have X movement, which is not what we want. We want movement in the Y. So let's just say to hell with it and just try the other axis. I don't feel like thinking about it. Well, the box is in the ground, but it's not stuck in the ground, because we're testing it as if it's centered on FatSack instead of offset from FatSack. So it's consistent, at least. It's consistently wrong, but it is consistent, so we can fix that later without actually worrying too much about it. So it's a bug we really don't need to fix in order to actually write movement, and then we can fix that bug later and just grab what we need. Now my first thing was like, wait, this math should have us just right on the floor, and the overlap test is succeeding, so we shouldn't be on the floor. So I hit the keys, and then he moved, and I was like, okay, so something is working. But he wasn't moving in the directions I wanted him to. So that's trying to move in the z-axis. So very clearly, by process of elimination, we're supposed to rotate about the z. I should actually go look at this F rotator, and it's probably that just yaw pitch roll in Unreal is just something else. Let's see if this does what we want. Hurry up and wait. So it looks like our character is moving properly on the floor, but then he like slows down. So I'll have to go take a look at that. No. It's like he's sliding. Okay, it's moving opposite to the arrow keys, so there we go for that. Let's see. Updating based on locomotion. We can get rid of that log line. And we'll be fixing all the little things, like our normals are not actually returning with a 0 in the X direction, so we're actually moving our character in the X direction and stuff like that, which we do not want to do. So tons of little things to clean up. Yes. Slidey fat sack. That's what's going to happen until we get all this stuff done. 4 a.m. Not tired. Insane. Thank you for following, Hozadak. How's your day going? Yeah, go get some sleep, Karakan. If you need to do stuff tomorrow, get some rest. So he's sliding around, kind of as he should. If I hit the up key, it's going to the other direction. Nice. So our velocities are totally messed up. Very good. All right, good. Glad you're having a good one. All right. So we're sliding along flat ground, which is exactly what should be happening. And our surface normals are returning the correct things. The movement direction is being rotated properly about that surface normal. So we need to set our movement direction vector dot x needs to be 0. Alright. The left stick has been changed to up. So we don't need that. So WD key mapping. Key mapping.cpp. Whatever. We'll find it. We'll find it in the hierarchy. Where are managers? Input. Key mapper. Hello, hi. Yes. All the greetings. We're just we're working on the movement right now for the characters. Right now we are working on the movement for when you're on the ground and making it so that you can walk up and down stairs, and that if you're right now we're just doing the basic thing of if you're a box and we're doing a sweep test over to the right, making sure that works, and that if we have like stairs going down, that you actually sweep out and then you stick to the stairs, so your dude is going to keep on them. And then, when you were moving down a slope, that, we do kind of the same thing. And, it's a slow process because we're just hooking up nuts and bolts. We're writing the functions we need to as we go. So it's not like a stream where I got everything set up to like bang it all out. Dashkin.com. That's true. Dashkin game. It's releasing Q4 2017. It's gonna be a big thing. Yeah, we also got Adam's site migrated over to the new server and all that stuff, which we'll be cleaning little bits and pieces up from that, probably. But hopefully saving him a bunch of money. And making it so we have, things like security. Yeah, I've been streaming the development work all week, and streaming games kind of in the evening for me. And it's all getting posted to YouTube as well. So if you want to catch up on the old ones, you can check the archives, or I've broken them up onto YouTube. They're a little bit higher quality on YouTube. They've got so they'll look a little bit cleaner. Yeah, I can't wait for it to be done either. It's gonna be pretty cool. Well, that's the hope at least. And I may be biased in saying how amazing the game is. But right now, it's Fatsack just sliding around, and it's the best game. Best game of the game of the year already. You know it. I know it. We all know it. It's gonna be great. So, yeah, we're going to need to know what is our wanted velocity here. So we should basically just be saying our movement direction vector should be kind of left or right. It should be pretty simple. We've got the surface normal, start position, movement direction vector, movement distance. The movement distance is the wanted velocity dot y times the delta t. So why don't we also print that out and see what our movement distance is. Let's see what we got. Let's see what we got going on. It's going to be a little boring while we're just kind of crunching out the numbers. It'll be a lot more interesting, when we're done. It's probably more interesting to watch the total crap movement I threw in, where I was just like, let's get a raycast, and okay, now Fatsack can fly around, and now he's walking, which is just all fake. Fake movement to test things out. This is more real stuff, so it's going to take longer. It's going to be much more boring. And all that fun stuff. So let's see, what do we got? And we're really just paying attention to the logs. Wanted velocity is negative 1,000 in the y direction. The surface normal is that the direction of movement is negative 1 and the movement distance is 5. Okay. So we're moving, and then like we slow down? Why is the movement distance changing so often? Because our velocity is not. Because like it's 5 and then it's 3, so it's probably that our frame time is so much smaller. And he's like moving back and forth here. If you see that, he's freaking out. Let's see what our actual position is looking like. In any actor, his location has actually moved quite a fair distance in the X. So if we set that to 0, as you can see, our X moved back to, our Y is changing, and our Y is actually constantly changing. Yeah, we're just moving back and forth. Our velocity is that, so our surface normal is that, and our movement direction is -1. Obviously we have more going on here than we want. So I'm curious as to why our X is getting set very quickly to 4, 4, 6. Could it be? Could it be that our impact points are all sorts of screwed up? Alright, let's go get our frames in here as well for our printouts. And we're just gonna do like a %D on the front for all these. So we will at least get a little bit more information as to which frame we're actually dealing with, because we have multiple physics updates each frame, so we're gonna wanna take a look. Alright, so hit distance, impact point. So what we're going to want to do here is, if we'd not hit anything in our sweep, so the hit distance for the sweep after, okay, so what we're doing here, we are, alright, so step 1, stick ourselves to the floor, or no, this is not sticking ourselves to the floor, this is see if we are flying. See if our ground has suddenly disappeared. Disappeared and collect information such as surface normals. Then what we're doing here is we're figuring out our direction of motion. And those all looked good, like our movement direction was looking good, but we moved in the X direction anyway, which is completely wrong. So movement distance. Movement distance also looked pretty good. So this is going to tell us, this else if here, we struck ground and are unable to move in our sweep direction. And we're going to want the impact point and the hit distance printed out for us. It's going to be the hit distance. And this is going to be, we did not strike any object in our sweep. Alright, excellent. So we did not strike any object in our sweep. We're then going to go through all of our components, and we're going to find the closest hit. So we find the closest floor to snap to below ourselves. So we didn't hit anything, so we must be in the air. So let's just do that. Info log. After sweep, we are in the air, as nothing is below us. So we are in the air as ground is too far beneath us. Okay, so then what we're doing is we are snapping to supposedly this new position. What are we setting new position to? It's going to be, the new position is our movement vector times this. So we should print out our position after the sweep is and then it's going to be new position x y and dot z. And our suggested new position is going to be this impact point plus the surface normal. So our suggested position after sweep is impact this suggested new position. And let's see what that impact point is. So impact point for downward sweep is impact point. So what I want to know is if this impact point is like totally screwing us. And let's also get the surface normal on that impact point. Surface normal on impact point on downward trace or downward sweep is that. So our suggested position after the sweep is this. We're going to do an overlap test, so we're going to then print out if our overlap test worked. Our overlap test hit something. Did not.